plus log 50. Now this one we can do in the calculator, right? So go ahead and do log 2 plus log 50 in your calculator. See what you get. They're both, either one by themselves is ugly. You just hit log 2 by itself, you get some ugly thing. But sure enough, if you do log 2 plus log 50, what do you get? 2. Now why does that make sense? Because, again, you have the same base, so the addition of powers means I can multiply. And sure enough, log of 100 is 2. Cool, right? This is the first property.
Oh, is that I thought that was a subtraction in between 2 and 50.
Oh, no, that's a times.
There you go. There you go.
There you go.
Hey, what buttons do you press? When I do log 2 plus log 50, I got like 0.568.
There's a log, I can't remember now.
Oh, yeah,
Is
you
log
did.
open in parentheses?
Yeah.
You gotta close it, yeah. I hate
Okay.
that. It's like Microsoft Word guessing what I want. Like, don't do shit, I can do it. So I hate all that crap when it opens a parentheses for it. Yeah, so
Okay.
they're with me. Alright, so the first property. I don't know if you guys realize this. I'm trying to get all this new stuff in before I take a break, and then after the break will be review time. Properties are logs. So the first property got is log base b of a plus log base b of b equals log base b of ab. Now if you wanted to, you can go backwards. So again, look at what this says. Knowing that logs are powers. When do I add powers with the same base? When I multiply the things with that base. Right? When I multiply the things with the same base, I can add the powers.
Nope.
And any example I give you is either going to be too complex and technical or too simple. So I'm not going to. Right. So what do you think I do when I subtract two things with the same base? Yeah, when do I subtract powers? When I divide. So at the very least, memorization of these properties should be easy because we all know our properties of powers. And they're the same damn things for logs. When I subtract powers, when I divide. Now, what level are you having a problem with this? Because as my students, I appreciate the fact the reason this is hard is because I try to get you to understand the concept, and that's not ever easy. The actual nuts and bolts of this is stupid easy, really. If you don't want to understand it, you're like, well, when I see two logs adding, I just make log and a multiply. I mean, that's stupid easy. But I'm really happy that you guys are frustrated because that means that's not enough for you. You're saying, I want to know why the freaking hell that is. You gotta be careful on that. I'm on tape now. What do I want? If you missed last class, it's too bad. So I appreciate that, but it's not the easiest thing in the world to see. Let me see if I can remember.
I'm having a hard time seeing the a plus log to b. I mean,
Here we go. Watch this. You ready? All right. What is log base b of a? Let's say that's now you gotta. I'm gonna show you something. It's the best I can really do. Tell you honestly. You gotta go with me here. What is log base b of a? Do we know?
Nope.
All right. So let's call it x. Cool. What's log base b of big B? What do you think we're going to call it? We don't know.
X.
Is it the same?
No.
No. So you got to give it a different name.
Okay.
If you give it the same name, you're telling me they're the same.
Maybe they are.
So what does this say then? A is what?
B to the X power.
B to the x. And this says that big B is B to the y. To the y, Jeff. Get it up. There you go. Baby. Right? So what is A times B?
B to X.
B to the x times B to the y. Which is?
B to the X plus Y.
B to the x plus y. Cool. Right? So you can see the, so then if I do this, let me see if I can finish this out. Log base b of a times b. Now let me really get you guys to go with me. whenever I try to explain things like this, people get lost in the alphabet soup. I understand that. We have to kind of do it that way, though. If I use specific numbers, you're still not going to understand, because, ooh, they work for the numbers yet. Is everybody sort of with me so far? I mean, it's actually not too bad what I've got up here. I don't know what the hell that is. I don't know what the hell that is. So that means I can rewrite it. Ooh, big deal. So what is A times B? That's really the big part here, right? A times B is that mess. So what's log base B of A times B? It's equal to log base B of B to the x plus y, right? Are you with me? If I do log, all right, so if I have, let me see, wait a minute. Let me go back a step. What does this really say? This says that A times B equals this. Is that cool? If I do something to one side, I have to do it to the other side. So what's log base B of A times B then? What did I do to this side? I took a log base B of it, right? What do I have to do to the other side? Yeah. Right? How we doing? So what is log base B of A times B? What happens on this side that's really nice? It's equal to x plus y. What was x? Log base B of A. What was y? Log base B of B. I don't know if that satisfies you, because that's still not quite there. But it's sort of like, if you ever look at pure law, any guys ever look at like pure legal language, the aforementioned party of the third part, well, you know, and then you have, could you explain that to me? What the hell? So here is the law. Here is the derivation of this property. Here's the way to look at it. Logs pluck powers off, don't they? I mean, again, what happened here? Didn't it pluck this power off? X plus y? Log base B of B to the x plus y just has an x plus y at the end, doesn't it? Take the power as the answer, right? It kills the rest of it. So logs give you the powers. So when I add logs, that must mean that I have the product of these two, because the power will be the addition of the powers. Oh, it's really difficult to say this all the way out, but hopefully you guys are kind of with me. Logs are powers. So this is saying, when I take the log of a product, that must be the sum of the powers of each of them. Because that's what I do. What do I do with the powers when I take a product? I add the powers. What do I do with the powers when I divide? I subtract the powers. Cool. Okay, maybe. So now here's the funny thing. The third property I can either do with number one or with another property of powers. So let me start with the property of powers. What do you do when you have something, a power raised to a power? What do you do with the powers? Like x squared cubed. What do you do with the powers? Multiply them. So that's why this becomes that power times this power. Now let me show you a different way to look at it. What is log base B of A to the m? Isn't it log base B of A times A times A times A m times? Cool, right? Couldn't I use then product number one over and over and over again? So I get this is equal to log base B of A plus log base B of A plus log base B of A m times. So how many log base B of A's do I have? M of them. So what's the shorthand way of saying log base B of A plus log base B of A plus log base M log base B of A? There you go. There's another way to look at it. The kick-ass cool thing about it is logarithms are the only things that can take powers and bring them down. Right? It's our first function that has that ability to have a power on something and it brings it down. It's kind of cool. It strips it away from it. Right? Okay, maybe. And that's actually, let me see if I skipped anything. I don't think that's everything. Yeah, that's everything. That's all the properties of logarithms. I'm curious, I didn't even look at how the book explains it. And they don't. That's one way around it. Here, Joel. No, here it is. Proof of the product rule, and they basically do the same thing I do. Yeah. That's the best way I've come up with how to do it. Alright. Good boy. Let's yeah.
How about something like 45 on page 742, where it's got the radicals?
Yeah, cool. So what this all boils down to then, let's look at a specific concrete example. Let's not jump right into that one. What this boils down to is if I have something like this, okay, if I have that, right? Now I have no properties that tell me what to do when I have 2 logs plus 3 logs. I do have a property that tells me what to do when I have a log plus a log. So what's in my way? Why don't I have log plus log? What's in my way? I know what to do if I have 1 log plus 1 log. I can do the product then, right? What's in my way then? The 2 and the 3. I can't just divide by 6 and they magically disappear, right? What I can do though is, where can this go? I can use this property in reverse. Any coefficient can go
Back to the
back
power
up here.
of W.
right? So it'd be log 7 w squared plus log 7 m cubed. So it's just using this property in reverse. Bam. So coefficients can go up and be powers, or powers can come down and be coefficients, whichever one you need for right then. And we've been doing this the whole time with functions that we know. That's why you're all like, this is new. No, it's not. It's just we're doing it with a function we're not used to. Right? Going both ways. So when I add logs of the same base, how can I rewrite that as a single log?
W squared plus, or no, times m to m cubed.
And when I add powers, it means I was multiplying. Right? You can always say that to yourself to make sure you did it correctly. So there's a practical application to this, right? That's the one that makes more sense, because math normally is all about consolidating. But sometimes they have problems where they say break it up. Take this big ugly log base a of the 4th root of a d over w cubed. Scheisse. There, that's my. I can just say it in different languages. Sure. Hey, we know how to cuss people out in sign language. Right? All right. Anybody know sign language? Really? Did I do that correctly? A little bit? All right. All right. You might not know some of the words. I know. But, this is kind of doing this in reverse. I want to break it up. So it's like you actually do everything in reverse. You do the powers last to make them coefficients, right? You do everything here in reverse. The very first thing I want to do.
Raise it to the 4th. 1/4.
Yeah, exactly. I can rewrite it like that. And actually here I can go against what I just said. I really want that out of the way, right? So can't I bring that 1/4 down? Just because it's kind of like the outside function. Let me get that out of the way. Now how do I rewrite that division? You normally start with the division first so you don't have the minus signs in the wrong place. And that's going to be 1/4 log A of the top. What do I do when I divide? Minus the bottom, right? So I can break that up. When I divide, I can rewrite as the difference of 2 powers, right? The difference of 2 logs. I'm just running through all the words. The sum is just the quotient of the difference. And then how can I break this up?
Add.
Yeah, when I multiply, that means I add exponents. And how can I break this? What's the one thing I can do with this? The power can come down. And then you can bring the 1/4 through if you wanted to, but that's plenty good. Again, this is brand new, obviously. Brand new. So don't make much sense right now at all. It's just thank God it ain't on the test tomorrow. Right? So let's take a break. When you come back, I'm going to focus on review for the test tomorrow. Come back at, say, I don't know, 5 after.